Hello, welcome back to a new lesson. This is Lakshmikant Tiwari. In this lesson, I'm going to show you how you can predict a Google stock price. So I'll be using here RNN and LSTM networks to predict a Google stock price. And the data for a Google stock price you can download from Yahoo Finance. And I'll be using here TensorFlow 2.0. A TensorFlow 2 you can download, you can install in your computer by using these commands. If you already have a TensorFlow, you can upgrade that TensorFlow. Otherwise, you can just write there the pip install TensorFlow for CPU only. But if you want to use a GPU, then you can use pip install TensorFlow -GPU. All right. And if you haven't watched my previous videos, you can go ahead at my channel KGP Talkie. There I have made so many videos on deep learning, especially on convolutional neural network previously, and there you can learn convolutional neural networks. And before that I have taught about feature selections and classical machine learning and Pythons and data visualizations into a Python. So there are a lot of the things to learn in my these channels at KGP Talkie. And apart from that, finally I'll be showing you how you can predict these prices very accurately, and then I'll be also talking about the LSTMs and introductions of the LSTM networks, and what are the type of the RNNs, and then what are the problems with the recurrent neural networks, and then how we can overcome with the LSTM networks. And then after this we will be doing here a step-by-step coding. So these things I'll be talking about the step-by-step. It will be around 50 to 1 hour, 50 to 60 minutes long lessons where you will be learning each and everything, and then finally you will be learning how you can improve your model. All right, so there are a lot of the things to learn in this lesson. Without wasting your time, let's go ahead and start this brand new lesson. Recurrent neural networks can memorize or remember previous inputs in a memory when a huge set of sequential data is given. So if you have already seen my previous videos on convolutional neural network, in that you might have noticed that CNN don't have any memory cells. I mean, the CNN cannot memorize the previous inputs, and the state of the previous inputs are the outputs, but the RNN can. And here you can see the example of this RNN, and it is kind of, there is a cell, and if we unloop this, unroll this cell, you will get something like this. So it is a kind of the multiple cell, and these are the kind of the multiple cells, but the repeating itself. And with this you can see here the first output is dependent on the first input, but the second output is dependent on a second input as well as a first input. And similarly you see here a third output is dependent on a third input as well as a first and the second input. So this is how RNN works. This is recurrent neural network. So recurrent neural network is a kind of having a memory of a previous inputs and the output as well, which is getting fed into a conjective outputs. And similarly for HT output, you see it is dependent on a XT input as well as a previous input as well. So these loops make a recurrent neural network seem kind of a mystery. However, if you think a bit more about this, it turns out that they aren't all that different than a normal neural network, which we have already seen in our previous videos. A recurrent neural network can be thought as a multiple copies of a same neural network, each passing a message or a memory to these successor neural networks. So something like this we can visualize. There are different kind of recurrent neural network, like one-to-one, one-to-many, many-to-one, many-to-many, and many-to-many. All right, see how. See in the first example, so we can say that like image classification, and in this we can say here a sequence output like image captioning. For example, let's say there is image where we can say that what type of image and what are the other information this image has, like there is a dog in the image and the dog is into a field and there is some caption into the image. So there is just a single input and the multiple output. and there could be a multiple inputs but single output, like sentiment analysis. That's mean like there could be a multiple the words in a sentence, and then it can give a single output, like what is the sentiment of a sentence. And then finally we can get something like many to many. In a many to many, like a translation, okay, like a sentence translation, like a Google translation works. English to French is English to Spanish, or English to something else, or some language to some other language translation. So that is many to many. And there is another synchronized many to many. A synchronized many to many is like video classification, where we wish to label each frame of a video. So this is kind of synchronized many to many classification. All right, so this is about a recurrent neural network, but recurrent neural network have a problem, and that problem is long-term dependency. For example, if we take a large set of recurrent neural network, then there could be two type of problem. One is the vanishing gradient, and another one is a exploding gradient. As you know, the neural network works on a back propagation. All right, if we get the output, we compare it with the actual output. If there is error, a large error or a small error, accordingly we updates the weights of a neural network. All right, so for example, let's say you have a big neural network here, a recurrent neural network, and weights get updated one after another layers. And if the output is error, all right, if this error is less than 1 for this first input layer or first input cell, then it get the multiplied by learning rate. Okay, so like here you see the W is equal to the W plus the weight, a small weight change, and this small weight change is N into DE divided by DW, that is the error. All right, the difference of the error. And you can see here the error is actual output minus model output is square. All right, so if error is less than 1, then this square will become very less, almost it will tend to the 0. Okay, and till this last cell. So this is how it is known as a vanishing gradient. That means the gradients at the last cell will vanish out completely. But imagine if this gradient is less, if this gradient is greater than 1, then what would happen? If gradient is greater than 1, then by reaching this end, it will explode. All right, because it is a square. The 1 is square, anything greater than 1 square will be always greater than 1. All right, and once we reach till this last cell, the gradient will the explode there. Explode, I mean the gradient will reach at the very high value. So this is how a gradient explode occur, or you can say the exploding gradient occur in recurrent neural network. All right, to overcome this problem, we have came up with the another version of recurrent neural network, which is known as a long short-term memory LSTM network. All right, so these LSTM networks usually just called the long-term short-term memory networks usually just called LSTM, and these are the special kind of RNN, and these networks are capable of learning long-term dependencies. LSTMs are explicitly designed to avoid the long-term dependency problems, and the remembering information for a long period of the time is practically their default behavior. And as you see here, these single cells has been updated with something like this. These are kind of you can say controlling inputs or controlling gates, which can actually controls the previous memory as well as the input. So this is how we are going to handle the exploding and the vanishing gradients into recurrent neural network. So these are the cell which you can assume that in previously we have into here in a normal RNN, normal neural network, recurrent neural network. But in the LSTM, we have something like this, where this sigma is kind of the activation function, and which is actually controlling the how much information we want from a previous cell. All right, so if you see here, if you want to control the previous output here, HT, the information from the previous output, then what we can do, we can just make small this sigma, and this then small sigma multiplied by this HT minus 1 will feed a small output, okay, will a small contribution from here. And similarly from this and this, we can control the information or the contribution of the XT. All right, so this is how we are controlling the memory from a previous cell, although you can see very detailed from here. All right, so this is how we are controlling this whole LSTM networks. So there you see here, this is the previous outputs, and here's current input, and this is previous memory. So this is a forget cell, and with this sigmoid function we can control how much information we want to feed, all right, in a previous states of in a previous state. And this is how we want to understand that how much information we want to transmit from the input as well as the previous output, and this is known as the output gate. All right, so with this sigmoid functions we can control how much output we want to give in the previous state, in the next output. So this is how it is being controlled. This is this seems a little complex, although with the help of the TensorFlow and Keras high-level libraries, this has been made very simple. So you do not need to worry about the implementing all these things, but you need to just understand how these LSTM is working. So this FT, this is a forget cell, this is controlling how much information we want to keep and how much information we want to destroy. All right, so this CT, you can say that this is kind of the memory cell or a state of the previous cell which we want to keep, and this is the output, and this is the output gate control, which is with which we can control that how much information we can keep from the previous output. All right, perfect. So this is all about the LSTM. Now let's go ahead and understand how we can predict Google stock price. So to download the first data of the Google stock price, we are going to download it from the Yahoo Finance. You need to go to this link. I have already given this link here. You can download this from there. And once you come to this link, there you get here a download data. But before download data, you need to select here a time period for how much time period you want to select. So here I have selected the max time period. A max time period, that's mean the data is available from 19th of August 2004 to 7th of October 2019. All right, so this is how you can download this. Once you download, you will get a full data almost from previous 15 years of Google Google stock price data. And then you see here it has multiple columns like a date, and then it has open, and what is the opening at this date, and what is the highest stock price at this date, and then what is the lowest price, and then at which price it has closed, and adjusted close price, and there is a volume of share. All right, so this is the whole information. And now let's go ahead. I have already downloaded this data. You can see here I have already downloaded this data and it is there. So I have already downloaded this 2 days ago. That's when the Google price stock is available from 4th of October. All right, perfect. So and now let's go ahead and see how we are going to work. So we will be reading this data into a chunk of 60 days. So we'll be training actually our neural network on 60 days data, and then we will be predicting on the 61st day. And then similarly, we will be again skipping the last data, I mean the one data, and then again we will be taking it, let's say, from 1 to 61 days, and then we will be predicting at the 62 days. And similarly, that's mean we will be reading here chunk of 60 days data with the hop size of the 1 day, and then finally we will be training our data, and similarly we will be testing our data, okay, based on this. So let's go ahead and see what are the steps in building a stock prediction model using recurrent neural network. The first we will be doing a data processing, pre-processing, and then we will be building recurrent neural network, and then finally we will be making a predictions and visualizing our predicted data. So first of all, we need to import numpy as np, matplotlib.pyplot as a plt, pandas as a pd, and a scalar min max scalar, so that we can bring our the output actually, so that we can bring our columns in the same scale, because these scales are the different. All right, perfect. So let's go ahead and start loading the data first. So the data we can load into a data is equal to pd dot read csv, and there we have google.csv, that's the google.csv file, and then here we are going to say that the date parser, okay, so we are going to say here a date parser is equal to true. All right, so let's go ahead and see the data first. So this is the what data, and this data is available from 19th of August 2004, and if you want to know the tail of this data, that is the 4th of October 2019. Okay, so these are the column like date, open, high, low, close, adjusted close, and the volume. For predicting our output, so we'll be using here multiple input. That's when we will be using open, high, low, close, adjusted close, and the value data to predict the final output. And we will be not including the date, since date doesn't give much information while predicting the final output. So let's go ahead, first divide this data into training and the test set. So here we can say data training is equal to a data. So what we are going to do here, we are going to take the data of 2004 to December 2018 as a training data set, and the Google prices of 2019 as a testing data set. So we can say here a data date, if it is less than of 2019 0101. All right, so it says that if date is less than this one, then yeah, of course we are going to create a copy. There you see this data training. All right, so this is the training data, and the training data is from 19th of August 2004 to 31st of December 2018. So this is our training data, and similarly we are going to take our testing data as well. All right, so let's go ahead and copy this, and we are going to just write here a test data, and this will be greater than or equal to the copy, and then here we have our test data. All right, so with this we have 2nd of January 2019 to 4th of October 2019. So this will be our testing set. Okay. All right, so let's go ahead and get the training data first of all. Okay, actual training data, so that we can get with the training underscore data is equal to data training, and there we need to actually drop, and there we need to first drop date, as well as we are going to drop their adjusted close as well, and that we are going to drop at axis is equal to 1. All right, so here we have a training data dot head. You see here, now these are the 5 columns which we are going to include in our final prediction. All right, So now you see here one thing, that we need to predict this open. All right, but how we are going to predict this open? We are going to first read it into a set of 60 days data. All right, in a set of 60 days data, and then we will be predicting 61st days of opening price of that stock. All right, perfect. So but before that, we need to get here a min max scalar. So let's go ahead and call that min max scalar, and we can say that the training data is equal to here scalar dot fit underscore transform, and there we have a training data. All right, so let's go ahead and see this training data. Now this training data has came into a maximum value of 1 and minimum value of 0. All right, so by default this min max scalar takes minimum value 0 and maximum value 1. All right, perfect. So let's go ahead and first create our training and training set, that is the X train, so that we can get with X train is equal to the empty list, and similarly we can get here Y train is equal to empty list. Now after this we need to we need to read the first 60 days of the data, and then we need to put it into the X train, and that we can do like for I in range of, there we are going to read from the 60 days, because you see here as you see here these first 60 days we need to make it as a training set, and then another 60 days, another 60 days. All right, although you can change this 60 days to 30 days or 90 days, whatever you like, but here in this lesson I'm gonna take it 60 days. And after that I'm gonna say there a training data dot shape, and then there is a 0. That means you can say that that is actually the length of our input. Okay, so that is the 3617. all right, so this is going to iterate from 60 to 3617, and then we are going to take that into the X train dot append, and inside that we have here a training data, and that training data we are going to take here from I, that I start from 60, that's mean I minus 60, that is 0, to I, that is the 60. All right, and similarly we are going to take that into Y train as well, and there Y train dot append, and inside this we have here a training data, and inside this training data we have I and 0, that's mean that is the 60th. Okay, that is the 60th the stock price at the 60th day. Okay, 60 days. All right, so how we are going to do, I mean with this we can say that the first 60 days we are loading into X train, and then the prediction price which we are going to predict, that is we are loading into Y train. But for the next iteration we are again loading from the first to 61 days into X train, and the 62nd days we are loading into Y train. So this is how it is going to happen. All right, so let's go ahead and run this, and now we are going to convert this list into numpy array, that we can say something like this, np dot array, and there we have X train, and then here we have np dot array, then Y underscore train. All right, so here we have now numpy array, X train, and the Y train. So let's go ahead and get the shape of this X train. So this is the shape of X train, which it has here, you see 3557, okay, the rows, and these are the 60 columns, and this is the 5-dimensional data. These 5-dimensional data, that's mean those are the 5 columns. Okay, we can visualize this, and similarly if you see here Y underscore train dot shape it has also 3557 rows. Alright, so with this what we have done, actually we have divided our you can say we have divided this data into kind of the 60 days. Okay, the 60 days of chunk into chunk of 60 days, and then finally we had converted into a NumPy array. All right, so this is how we have prepared our training data set. Now let's go ahead and build our recurrent neural network. And for building neural network, we need to first import our sequential data set. Sorry, we need to import keras layers that we can do from TensorFlow dot keras import sequential, import sequential, and similarly from TensorFlow dot keras dot layers, and from there we are going to import first dense layer, and then we are going to import LSTM layer, and then finally we are going to import a dropout layer. All right, perfect. And now we are going to create our model, LSTM model. See here, we are going to call it regressor because we are doing here actually the regression. Since this is continuous value prediction, so in continuous value predictions we do regression, but in categorical value predictions we do a model selection. All right, so here regression is equal to the sequential, and then here we are going to add a 4 layer of LSTM. All right, so here we have regression, sorry, not regression, but in fact call it regressor, and there we have a regressor, sorry, regressor dot add, and inside this add we have here LSTM. All right, so with this add we have LSTM, and inside the LSTM, if you press shift and the double tab, you will see here there is lots of the input which it takes. Okay, lots of input. Okay, so these are the input parameters which we can pass to our LSTM. So the basic input parameters like units, how many units we want. That's mean, for example, this is our LSTM networks. So these are the input layers, are units you can say. So how many units we want in our LSTM network. So the first we are going to say that we need 50 units, and then we are going to select here, you see, the activation function. So what is the activation functions which we are going to select there? The activation functions we are going to select ReLU, and after this we are going to pass here a return sequences, that is the true. What is the mean of return sequences? If you see here at the first cell, for example, let's say this is the first the LSTM, whether we want to return this input sequence to the for a next layer or not. Since this is a multiple layer, since we are going to implement a 4 layer of LSTM network, that's why we want to return a sequence from first layer to another layer. After this we need input shape. All right, so for input shape, and what would be the input shape? Input shape is really simple. I mean, what will be the input shape? That is x train dot shape, and that is the one dot shape, and then finally 5. So this is the input shape, and if you want to see what is the input shape, we can just copy and paste it here. So this is our input shape for a single layer. So there would be a 60 by 5. All right, so this is our input shape, and there is 3557 rows, and each rows have a shape of 60 into 5. All right, so let's go ahead and run this. So you see here this runs very beautifully, And then inside this regressor, since we need to generalize our model, we are going to add here a dropout, and that dropout is just a 20% of dropout. Alright, so let's go ahead and add the another layer. For another layer of this LSTM, we need to just copy it and paste it here. Alright, and then we are going to just increase this units, LSTM units 50 to 60, and activation functions would be the same, and there is just simple change, that's mean we don't need this. Okay, alright, so we don't need this, and once it is done, then after that we are going to add here 30% of dropout. That's mean 30% of neural network neurons randomly will be dropped here to provide a better generalization. So let's go ahead and copy this and paste it here, and in this we are going to put here 80 units. Okay, inside this 80 units we are just going to put here 40% of dropout, and then here we are going to put here a final layer. Inside a final layer I'm going to put here 120 units, and their return sequence, we don't want return sequence because this is final output, and there I'm going to put here a 50% of a dropout. After that, as we have done into our convolutional neural network, we need to add here a finally dense layer. Okay, that's the output layer. There is just a single output, that is why units is equal to 1. Alright, so now you have your model ready for LSTM, and now let's go ahead and print the summary of this model, which we can get for regressor.summary, and this is summary of this model. So there we have 179,561 parameters in this our regressor model, LSTM model. Now let's go ahead and compile this model. Now you can remember this is kind of a similar techniques as we have done into our convolutional neural network in previous videos. So here we have regressor.compile, and inside this we have here the optimizer here, the optimizer, and their optimizer I'm going to pass here Adam optimizer, and then the loss function which I'm going to pass here. That's loss function. Since this is a regression problem, we are going to pass here loss function mean squared error. Alright, so this compiles our model. Now we have reached into a final stage of this model building, that is a training of this model, that we can train with x_train, with y_train, and then number of epochs we want to train it just for 10 epochs, and in the batch size, the batch size of the 32. Alright, so let's go ahead and run this. It will take a little time to complete this training of the model. Okay, so just wait for a few let's go ahead and wait for a few minutes to complete its training. So the training is done, and here is minimum loss, which is around 0.0028. Although you can make some changes into this model, like changing a dropout layers or a number of units, you can also further reduce this total loss of this model. Alright, so our model training is done, and now what we need to do, we need to test it. Now we need to test this model and predict a Google stock price, and for that we need to first prepare our test data set. So let's go ahead and first write here prepare test data set, and for preparing a test data set, you need to understand one thing here. Basically, for example, if we want to predict a price of this day, then we need to also have a price of previous 60 days. All right, that means, as you see here, we have taken the data in our the data test. You see here inside the data test, if we want to predict the price of this day, we need to get the first previous 60 days of the data, and which is inside the data, which is inside the data data training. You see here, this is data training, and there we have a tail and 60. All right, so this is previous 60 days of this data. I mean, to predict this first day of this opening price, we need to first have these last 60 days of the data. All right, to do that, what we are going to do, we are going to first get their past 60 days of the data. All right, so there you can say here past 60 days. So the past 60 days of the data we can get from the data training, then dot tail, and there 60. So this is the last 60 days of the data, and then we are going to append this data into our test set. And once we append this data into our test set, then we can predict our the stock price from these days. All right, so to do that, we are going to say here TF is equal to the past 60 days dot append, and inside this we are going to append here a data test, and then we are also going to here ignore index, that is the true. All right, okay, now you see here it says that yeah, ignore index, and now you see here DF. Now you see DF is available from 4th of October 2018, that is past 60 days of the data from 1st of January 2019 to the current date, which is 4th of October 2019. All right, and now what we are going to do here, since it has a date as well as adjusted close, we are going to drop those. All right, so here DF is equal to DF dot drop, and inside that we are going to first drop date, and then we are going to drop here ADJ close, and that drop is gonna happen at axis 1, and then finally you see here DF dot head. Now we have these 5 columns which is necessary for a prediction. All right, so here once we have got our the data frame DF, now we need to scale down these values from this highest value to 0 to 1, which we have already done during a training. So let's go ahead and say it as inputs is equal to scalar dot transform DF. Now you see here inputs, now it is in between 0 and 1. All right, so we have got our input. Now as we prepare our test set, training set, similarly we are going to prepare our test set. So x underscore test is empty list, and then y underscore test is equal to empty list. All right, and then here for I in range, and there we have 62. There we can say they are the inputs dot shape, and that is the complete length of this input. And then finally, as we did into a training set, x underscore test dot append, we can take it from inputs, and there we have to take it from the I minus 60, that's mean the 0 to ith location. All right, and similarly we have y underscore test is equal to y underscore test dot append, and there we have inputs, and here we are going to append the opening. Okay, so opening stock price, so that is I minus 0. So this is opening stock price. So with this we have got x test and the y test. All right, so let's go ahead and get the shape of x test and the y test. So it says that it doesn't have any attribute shape because this is list, and to make it first the numpy array, we can say that x underscore test, then comma y underscore test is equal to np dot array, then x underscore test, and then and then np dot array y underscore test. So with this we have got here the shape of x. So the x test has a total 192 rows and each rows have a shape of 16 to 5. All right, perfect. So this is how we have got our test set, and now finally we are going to predict it. Okay, so ypred, the ypred is equal to regressor dot predict, and in this we need to pass here x underscore test. All right, so the prediction is done here. Now you can see here ypred, this is the predicted value of y. So we already have y underscore test, the test and the predicted value. All right, so what we are going to now do, these values are scaled down. Now we are going to bring these values into a normal, okay, in the normal scale. So we have already done a min max scaler. Now we need to do inverse scaling. So how we can understand that what was the scaling level? The scaling level we can get from scale dot scale underscore. So with this we can say here, so this was a scaling level for a first column, which is open column and which is actually y test and y predicted. So we need to divide our y test or ypred with this scale. So if you copy this or just 1 by this, okay. So this is the scale. All right, so the first column was divided by this value to bring in between 0 and 1. All right, so this is how we are going to multiply this ypred and y test to bring it into a normal value. So we can do that. Y underscore pred is equal to y underscore pred, then multiplied by scale, and similarly y underscore test is equal to y underscore the test multiplied by scale. So with this we have got ypred and the y test into a normal scale. All right, so these are the normal scale. Perfect. So this is how we have got ypred and the y test. Now we are going to visualize our visualization. All right, so this is visualization. You can say also yes, so this is visualization of the output. We can visualize this. I have already written the code. Let's go ahead and get that code there, and in fact we don't need this, so we can just delete this. All right, so here you see the figure size. Here with this we are getting a figure size, and this we are going to plot the test set y test, that is the real value, actual value of stock price, into red, and here this is a predicted value of Google stock price, and the title is gonna be Google stock price predictions, and then XY labels finally. All right, so with this you can see here, this is how we are getting a Google stock price. So with this plotted graph we can see that this is not the most predicted Google stock price prediction. So as I told you earlier that you can make some changes into a model and you can increase the training time and the epochs. In fact, not a training time, you can increase the epochs for which you want to train your model, and then finally we can do. So I have made here some changes into our model. So you see here the first layer of LSTM is containing here 60 units, and the second as well containing 60, and the third one is containing 80, and the fourth one is 120. And the dropout is here just 0.2, that's been the 20% of a dropout, and all other things are the same as we built previously. Okay, so these are the things in the way you can improve your models. So you need to change the units, dropouts, activation functions, etc. to understand how your model is improving. So I have changed it, and then again I had the run our model, finally. And this is the loss which we have got. Earlier you might have noticed that minimum loss we had got around 0.0028, but here we have got really very low loss, which is around 0.000064. All right, so this is really very low loss. So the low loss means better accuracy during a testing. So once you have retrained your model, then you need to do again predictions and the plotting. So you can just run this cell again after prepare data set. So we run these cell one after another, and now we can see here a new y predicted value, and then finally here visualization. All right, so with this new visualization you can see here we have got a pretty much a more accurate stock price prediction. Earlier we had a lot of the offset, but here now we can get a lot of the non-linear predictions as well. So there are also more chance to improve your LSTMs, and you can test that. You try to reduce the total loss even below than this. You will notice that you will be able to predict your the stock price in more better way. All right, so this is all about in this lesson. Thank you so much for watching this video. Please do not forget to like and subscribe this channel. Bye bye, have a nice day.